Alright, so welcome to the video, and in this video we are going to solve these questions from tutorial sheet 1. So basically these are like the most challenging questions in the tutorial sheet 1 ma110 2026 academic year that we've observed. So we are focusing on the toughest questions. Yes, so if you guys think that I've skipped some of the questions which are challenging in this tutorial sheet, make sure that you text me. I'll record a video solving them. Right, so these questions are from the absolute values, which are also called the moduluses. Yeah, so this video will be focused on solving questions. Okay, of course while solving I'll be explaining, but my focus will be on solving because there are other videos where I've explained, where I've like taught. It was like a lesson which was focused on teaching, on making you understand. And these video lessons are found on the A Plus Academy app or the A Plus Academy platforms, which you can also access on Telegram. So if you want to watch these videos, make sure that you subscribe to our tutorials. Okay, I've explained each and every concept in depth. Yeah, so this video will be focused on solving, and make sure that you grab your pen and paper so that you can be solving along. Okay, so without any further ado, let's get started. But one more thing, even if you don't have any idea about how to go about the absolute values, by the end of this video you are going to have some ideas. Okay, because I'll be explaining while solving, so it will be like the easiest way to understand. Right, but make sure that you subscribe to our online tutorials where you find like the video lessons where we've already taught everything. Like you watch at your own pace so that you can easily understand while I solve these tutorial questions. But even if you don't, you can still watch this video and follow along. So let's get started. Alright, so before I dive into solving, as we solve these questions here, let me just introduce you to some of the basics that we're going to be using as we are going to start solving. So modulus, or the absolute values, these two words are used interchangeably. Okay, and the modulus is presented by this symbol where between we have a function. So I'll just walk you through some of the concepts that we are going to use as we will be solving these questions. But if you've downloaded the A Plus Academy app, or if you have subscribed to our tutorials, there is a video lesson on our platforms where we have taught everything deeply, because this video is designed to be short. Because I want to focus on solving and I won't dive deep into explaining like everything that has been explained in our video lessons. So here I'll just talk about some of the concepts that we'll use to solve these questions. But there are other concepts which, if I were to explain them right now, they would take long. That's why there are special lessons for that on our platforms. Okay, so let's solve these questions now. So I was talking about the concepts, right? So this is f of x. It's a function. So between here there will be a function surrounded by the moduluses. So some of the cases whereby you have a linear function, for example, maybe you might have 2 plus x, then they are surrounded by the moduluses. Okay, now the first case is where you have the modulus like this wrapped around a linear function, and then or this type of function, maybe where you have x plus this and that, or this and that plus x. This is a linear function, and there is an equal sign here, so you need to be very careful. Let's say here is -1. So the first case is whereby you have a negative number here, and here there is an equal sign. If there is a negative number here, it means that this has no solutions. Even though there's no question which is involving this, I've just explained it anyways because it's important that you know this. And then now this is important, so let me say case 1. So case 2 is whereby maybe you have a modulus like this, 2 plus x, and there's an equal sign here, and maybe this time there is a positive number here. Let's say positive, 1. So whenever you see this, you need to know that this function which is wrapped around the moduluses, it is either positive or negative. It's more like you have this. So the way that you solve this is to break it down. But how do you break it down? You break it down by saying you're going to split. You're going to say, so since it is either positive or negative, first you're going to take any sign first. So first let's take the positive. So let's say it is positive 2 plus x equal to 1. So this can either be this or it can be negative 2 plus x is equal to, I've put a negative here in front, then the number that is here, which is 1, right? So basically what you do is you solve this and this. Whatever values that you get for this and this, those are your values of x for that modulus function given. So you're going to solve this. Now the way that we simplify this is by dividing the symbol that is here throughout. So you can say over positive, we just remain with 2 plus x is equal to 1, right? Then here I would divide through by what? The negative symbol that is here. So it will be negative 1 over negative 1. So this and this will cancel and remain with 2 plus x is equal to negative 1. So if you've seen, I've ended up with here having the one that is positive, and here there's the one that is negative. So the easiest way is that whenever you see a modulus like this, just get what is here, you write, for the first one, equate to positive 1. For the second one, equate to negative 1, or the negative of whatever is here. So whichever way, but me, I won't be showing you maybe this part. Like, I don't know if you've observed, the majority of the tutors, they don't show this part. They will just show that they have written this twice, where the first one is just having positive, then the other one is having negative. So this is where the sign comes from. So this is the case. And then the other case is whereby, so let's say you have modulus of negative 1. So one thing that you should know is that any constant number that's wrapped around the modulus, okay, let me say that again. So any constant number, like any number around, or let me say the modulus of any number is always positive, or any modulus wrapped around a constant number, it will give a positive output. So mean that in a case whereby you have a negative number in the modulus, it will always give you a positive of that number. But why? Remember I told you that modulus is either positive or negative, right? So imagine now you have negative 1, mean that it can either be positive times negative. Okay, this negative will be gotten rid of by this negative that is found here. When we multiply what is inside with the negative here, it is going to cancel this negative here. So eventually there's going to be just a positive 1. But you don't need to know this. This is just a concept, like the logic behind this concept. The only concept that you should know is that whenever we have a negative in the modulus, it will always give you a positive value. Okay, and then the other concept is whereby now instead of having equal signs here, they might put signs like less than or greater than. So I'll use the same 2 plus x as an example, but we are going to start solving. When we start solving, we apply the tutorial sheet questions. Alright, so let's say an example. This is, I think, let's say, let's call this, I'll call it the case 3. So there's the first case, second case, third case, and then the fourth case, let's say case 4, is where maybe you have 2 plus is why you have modulus inequalities. For you guys who have access to our video lessons on our platforms, there are 4 video lessons for these, whereby on each case I'll solve like tons of questions from the tutorial sheets. So make sure that you watch those videos. For you guys who want to subscribe, make sure that you contact me. I'll put my number in the description, so in the comment section there, or in the video I'll put my number. Alright, so now instead of having an equal sign here, there can be an inequality, meaning that there can be a sign like greater than, less than, or the equal to. Greater than or equal to, or less than or equal to. They can do that. Now in this situation, how do you solve this kind of question? Like, how do you go about solving this question? So there are 2 cases. There is a case whereby they have, so in a case whereby what you have here is a less than, so it can be less than or equal to. So it can be less than or equal to, or less than. Okay, and here there can be any number, and make sure that the number is a positive for you to apply this. Okay, let's say it's a modulus. What you're having here is a modulus, and then the number that you're having here, let's just say it is 1. So in this case, what you do is this: you are going to get the number that is here. So you're going to remove these moduluses, get the number that is here, make it a negative, maintain the sign that is here, then write what is here, what is in the moduluses, but here write it without the modulus, without the moduluses. And then you now write what is here, separated by the symbol that is here, which is the less than or equal to. Then you write the number that is here, which is positive. So if you haven't gotten the logic, just know that you have to write the function that is in the modulus. You write it at the middle. Then on this side you put the number that is here as a negative, and on this side you put the number that is here as a positive. Then you start simplifying till you reach your final answer. I'll show you how to simplify with a tutorial sheet question from your latest tutorial sheet. Okay, now how about a case whereby there is greater than or equal to. So let's say you have, this is now case 5. There's another case which maybe I'll explain with a question. So I'll explain how I start solving. So make sure that you watch the solving part. So this is the last case now. So case 5 is, let's say you have 2 plus x modulus, but this time this greater than, or maybe let's say greater than or equal to. So you only apply this if it is greater than or equal to, and this if it is less than or equal to. So in a case like this, let's say there is 1 here. So in a case like this, you're going to split it. Okay, you're going to split it. You're going to split it like this. So it's going to be 2 plus x. Maintain the sign. So for the first one, maintain the sign that is here, and it is going to be a positive value. So maintain the positive value, you maintain it. And for the other equation, you write what is here without the modulus, which is 2 plus x, and then you change the sign. If it is greater than or equal to, you change it to less than or equal to, and then you write the number that is here but as a negative. Now you might be wondering, like, where is this coming from? If you remember, but okay, let me just say this. There is a video, I think, here on YouTube where I explain this. Just right to scroll through. I explain the modulus inequalities, like how we reach here. So I think these are the basics that you need for you to be settled when you start solving the questions. So now let's solve the questions. Alright, so we have a question here, the first question from the tutorial sheet. So if you've understood the basics which I've just explained in less than 10 minutes, you can even solve this. So now, if you remember the concept that I've just introduced you to, how can you solve this question? So for you to solve this one, remember I told you that if you have an equation like this, and here there is an equal sign, what do? You're going to split it, right? You break it down. The first one is going to be x minus 2 is equal to 6. Or the other one is going to be x. So for the first one, we don't change anything. The second equation, you write the same thing here, and you just change what? The sign of what is here. Right? So you're going to solve them now individually. So let's solve this. So it will be x is equal to 6 plus 2, right? When we take this on the other side, then it's going to be x is equal to 6 plus 2, that will be 8, right? So we found one value of x, and then we come here. So here we take this on the other side. So first we're going to have x is equal to negative 6 plus 2, right? Then x is equal to negative 6 plus 2, that will be negative 4, right? So we have two values of x. There's this one. The value of x can either be 8 or 4. Now you might be wondering, like, are you sure, Joseph? Yes, try to prove this. Put 8 where there's x. If you put 8 here, it's going to be 8 minus 2. It will be 6. If you put negative 4 here, so basically, if you put negative 4 minus 2, this is going to give you negative 6 in the moduluses. And this is the same, because anything that's in the modulus will give us positive. So you can even be proving your answers if you are doubting. That's the good part about this math. So this also proves that I'm teaching you correct stuffs. Okay, so let's go to the next question, and we go to B. So B is a phrase like 2n plus 1 is equal to 11, right? So even this, you do the same thing. So we're going to say 2n plus 1. So the first equation, it's like write the exact equation, just get rid of these modulus signs. Don't know if you should call them the modulus symbols. And then we say equal to 11. Or the other equation is going to be 2n plus 1. Then we change the sign of what is here. So these rules only applies where you have an equal sign here and what? And also the... Okay, let me just say... Oh, okay. Yeah, why you have an equal sign here. And then here it will be negative 1, 1. So let's solve this one here. So it's going to be 2n is equal to 11. We take this on the other side, it's going to be negative 1, right? So here we have 2n is equal to 10 over 2 over 2. So n is going to be 5. So the other value of n, so when concluding your answer, just say the answer is 8. X is either 8 or x is equal to negative 4. You even do this. That's how you can conclude. If your lecturer is very strict, there are some lecturers whom when they are marking, they just focus on the final part. You even add these symbols, which was therefore. They'll just focus on the final answer. They won't want to say this. So if the lecturer is of that kind, it will be easy for you to get marks. Right, so we come here, and here we have, so you just say 2n is equal to negative 11, right? Negative 11. So we take 1 on the other side, it will be negative 1, right? So we have 2n is equal to negative 12. So over 2 over 2, so n is going to be what? Negative 6. So there are two possible values of n. N can be 5 or 6. You even conclude as I've showed you. So we quickly go to C. So C is it's quite tricky. So C, I think I'll start this on a new page. All right. So we have this question here. So the same thing that I told you. So we're going to split this. So it's going to be 3 over k minus 1 is equal to 4, or 3 over k minus 1 is equal to negative 4, right? So we solve each one individually. So here I'll put 1, cross multiply. I'll use this simple mathematical method. So we cross multiply, it's going to be 3. This times this is going to be, so 3 is equal to 4k minus 1, right? So 3 is equal to 4 times k, it will be 4k. 4 times this is going to be negative 4. So I'll take this on the other side. It's going to be 3 plus 4, right? Then here I remain with 4k. This is 4k. Then over 4. And this is 7 over 4, right? Okay, so basically k, the first value of k is 7 over 4. Then we come here now. So we come here. So here what you're going to do is that I'll put 1 here, we cross multiply, it will be 3. Here we have negative 4k minus 1. So here we have 3, and then this times this, it will be negative 4k plus 4, right? And then we make k the subject. So first I'll take this on the other side. Then it's going to be 3. 3 minus 4 is equal to negative 4k, right? So 3 minus 4 is going to be negative 1, right? And here we remain with negative 4k, right? Over negative 4 over negative 4. And then this into this, so we say k is equal to, these are going to cancel each other, right? So we are eventually going to remain with 1 over 4. Have you seen? So we've solved this. So the possible values of k are either 7 over 4 or 1 over 4. We move on to the next one. Alright. So we have another one here. So this question, we do the same thing. As long as there's an equality sign here, same approach. So first, I'll write like the exact equation. I'll just get rid of the modulus symbols. So we're going to have x minus 2 over 3 equal to 3 over 4. This will be our first equation. The other equation is going to be x minus 2 over 3 is equal to negative 3 over 4. Right? So, listen. The easiest way to solve this is, okay, let me do this. The easiest way to solve this question, okay, I don't know, use any approach that you want. But we take this on the other side. So it's going to be x is equal to 3 over 4, right? This is going to become positive 2 over 3. Alright, so when you do this, then make this a single fraction. I mean, yeah, you just have to make this a single fraction. You can't leave your answer like this. So you have to say, you call it the common denominator, right? When you multiply, it will be 12, right? This into 12, it will be 3. 3 times 3, that is 9, right? 3 into this, it's 4. 4 times 2, that is 8. 9 plus 8, and that will be 17. So x is going to be 17 over 12, right? And then now let's solve this one here, the one on the right side. So even here, this one, you take it on the other side. X is equal to negative 3 over 4. Now the sign will change, right? 2 over 3. Make it a single fraction. So it will be 12 here. 4 into 12, that will be 3. 3 times, that will be negative 9, right? And then 3 into 12, that will be 4. 4 times 2, that will be 8. So x is equal to, this will give you negative 1 over 12 when you sum this up. So in case you still don't understand the moduluses, like you want to understand them deeply, because I think the questions that are in this tutorial sheet 1 under modulus, they are not all the questions. There are more questions under moduluses. There is graphing, but that is found under functions. I don't know why they have put this in tutorial sheet 1. Okay, I don't know why, but yeah, but on functions we'll go deeper. We even look at redefining the moduluses, and those things have been taught. So if you want to understand this topic properly, watch our arranged videos on Telegram, on our platforms, and on our app website. Like our videos are on different platforms so that you can easily access them. these are videos in order, in which they are arranged in order in which you need to watch the videos to understand them. Alright, so this one you've solved just like this. So it can either be this or this. So let's look at the last two simple questions. So here I'll put negative. The question is like this, -4. They want you to solve this. And remember, I told you that if any number, the modulus of any number is always be positive. So just say +4. Simple as that. And the other question, which is question F, is the modulus of 4. Now this doesn't mean that it will change to negative. No, it will still be +4. There's no way the modulus will output a negative. It is impossible. It is mathematically impossible. Alright, so yeah, that's how it goes. So we have E, we've solved E and F. Okay, interesting. So let's move to question the G, this one here. So this one, and solutions for these tutorial sheets are already there. I've solved the whole tutorial sheet for you guys who just want to revise by reading, like not watching the video like this, but by just whereby you solve, you just check in the document to confirm. The solutions for tutorial sheet 1 are already on the app, on our platforms. We've already solved it. So as we solved all the tutorial sheet questions for all the courses. So the tutorial sheet are already there. So G, we have 2x minus 3 less than or equal to 5. Alright, so we have this question here. So how do you solve this kind of question? This one is different because it is having a symbol here instead of an equal sign. And remember, I told you that if the symbol that is here is less than or equal to, you use a different approach. So you get what is here, you write it but as a negative. So it will be -5. The symbol that is here, less than or equal to, then you write what is here, which is 2x minus 3. Again, the symbol that is here. Alright, so here you rewrite the number that is here, which is +5. So now after you do this, here's how you simplify. So your goal here is to end up with x. This is x, guys. So you need to simplify this expression in such a way that you eventually end up with just x. So what to tell you how you move, what you do is whatever you're having here. So if you see here, for me to remain with x, or for me to remain with 2x, something that is having x, I need to get rid of -3, right? Now, how can I get rid of -3? I can get rid of -3 by introducing +3. If I add +3 to the expression that is between, at the middle, this middle expression here, the middle expression. So if I add +3, it will cancel the -3, right? And I just remain with this. Remember, I'm aiming to end with x, so I need to move step by step. Now, you won't just introduce +3 at the middle. You introduce everywhere, meaning that here you introduce +3, here +3, and here +3. So when you write your expression, it's going to look like this. So it's going to be -5 here, and +3 less than or equal to, and then here there will be 2x, -3, +3 less than or equal to 5 plus 3. Makes sense, right? Alright, so have you seen? So now you simplify each part. So this part, if you simplify, you're going to end up with what? -5 plus 3. You're going to end up with -2, right? You write the symbol, simplify the middle part. So the left side we've simplified and it has given us. So remember, what will tell you the number that you add on these other sides? It is at the middle. That's what the whole story is. Once you understand how to manipulate this, remember your goal is to end with 2x, because 2x is the one that is having x. But our goal at the end, like eventually, is to just end with x. And I'll show you how we are going to get rid of the 2x. So let's simplify this part here. So at the middle part, this will cancel, right? And you just remain with 2x. And then less than or equal to 5 plus 3, that will be 8. and then here we have negative 2 less than or equal to 2x. 2x less than or equal to 8. Here we have 2x. Now, how can I end up with x at the middle? We need to end up with x at the middle for us to reach our final answer. So I'm going to divide through by 2. So divide through by whatever is in front of x. That's the only way in which we are going to end up with x at the middle. So we cancel out. So eventually we are going to have this into this. It will be negative 1, right? Less than or equal to. Here there will be just x less than or equal to. This into this, that will be 4, right? So this is your final answer. Just like this, you are done. This is the simplest method, right? So let's look at another question. This is G, right? Let's go to question H. Alright, so we have another question here, and as you can see, there is less than symbol here. This thing of having to write, the way I've solved the previous question, it only applies if you have a modulus and there is less than or equal to or less than only. And there is another way of solving this type of question. Check on this same YouTube channel. I've already taught. There is a video on absolute values. I taught the other method where you use a certain method, then at the end you intersect your answers. Yeah, but this is easy. This method which I'm using is much easier if you understand it, and I want you to understand it. It will save your time during an exam. Okay, so let's solve question H. So this one, we are going to do the same thing. So we begin with what is here, but we put a negative, right? Negative 8. Get the symbol that is here, less than or equal to, and here we have 5x minus 4, less than or equal to positive 8. Alright? Yeah, so this is what we have right now. But how do we proceed from here? If you know. So what will tell you the number that you're going to add on all the sides, like if on this side, left, middle, and the right side, is this middle part. So you need to check. I need to end with x, but first I need to get rid of negative 4. What number can I add to this expression at the middle? For me to get rid of this negative 4, it is positive 4. So I'll add that positive 4 on all the sides. So starting with the left side, I'll say negative 8. But I'm adding positive 4, right? You come to the middle part, you say 5x negative 4 plus 4 less than or equal to, so 8 plus 4. Right? And then we have negative 4 and 5x less than or equal to, if you simplify this, you end up with this. If you simplify this and this will cancel, we just end up with 5x. Then here you add these two, 8 plus 4. 8 plus 4 is going to give you 8, 9, 10, 11, 12. Here it's going to give you 12. And then remember, we have 5x at the middle, right? We need to get rid of 5. But how? We need to divide through by 5. So it's going to be negative 4 over, negative 4 over 5 less than or equal to. This and this will cancel, right? So we just have x here and 12, 5. So this is the final answer now. But while you can simplify, try to simplify. Just that we can't simplify this any further. So let's go to question 10. Alright, and we have this question. So the easiest way to solve this question is to square both sides, you raise them to the power of 2. This is a case where you have a sign here and you have two moduluses. This side is a modulus and on this side is a modulus. Of course, there is another method of solving this question. And the method is lengthy. Like you need to draw the sign table. I think I'll show you the other method. It will require you to know some concepts on functions. So when you do this now, you expand each side. So it's going to be x minus 1 So this can also be written as this, right? I'm trying to show you the easiest way to expand since you guys don't use calculators, but myself I have a short method. So you expand this times this, it's going to be x this times this times this, negative x plus 1, that is this time that, x power 2 plus x plus 1, right? So here is basically like we have x power 2 minus 2x plus 1 is done, x power 2 plus 2x plus 1. We're just expanding. Okay, so this one is going to cancel with this one here. Why? Because if I were to take 1 on this side, it's going to be negative 1, which is going to cancel positive 1. So you can just cancel, or just cancel those stuffs which are corresponding, like they are having the same figures and same signs. So eventually we end up with x power 2 minus 2x less than x power 2 plus 2x. This is 2x. Right. Now it's the time for you to solve. And the other thing that we can cancel is this. I almost forgot. So even this will be cancelled because they are corresponding. So eventually we end up with, and like this. So now you can divide through. Remember, our goal is to end up with x, right? Our goal is to, no, here we can't divide through because here is x, unless there wasn't x here. So since these are like terms, you can just take it on the other side. Then it's going to be negative 2x minus 2x greater than 0. Since these are like terms, basically you have negative 4x, right? Divide through by negative 4. Now there is a certain principle on inequalities. Whenever you divide like this into a certain number, which is 0 in this case, and then that number which you dividing into the one on the numerator is having a negative, the sign here will change. It's like it's going to flip. If it was less than, it will become greater than, and vice versa. So here, first of all, yes, they will cancel here. We have x, but the sign will change. Here it is greater than, right? But it's going to become less than. This into 0, it will be 0. So the values of x are those which are less than 0. So you can even write this as in intervals. In intervals, you can write this as negative infinity to 0. In case they told you to write this, if they told you to write this in intervals, or you can just end your answer here. So this is another way which you can solve. Alright. So here's how we're going to. Okay, so let's solve this question. So now this question, we are having a symbol here. Now this is different from what we've been solving. There's a question now, question 10. Yeah. How is it this different? Because there was that question whereby we would we find what we can add to get rid of this and that. But here we don't do that because we have greater than symbol. Listen, if we had less than symbol here, if there was less than, we would have done this. We would have written negative 3 less than x plus 2 less than 3. Those stuffs. Only if there was less than. But if there is greater than, we don't do that. Okay. Instead, we just now do this. By the first expression, we write it. So the first expression, write this whole equation without changing anything, but just get rid of the modular signs. Then we say greater than 3. This will be first one. Okay. And then the other equation, you write the exact equation, but you change, the first thing that you change is the sign and the number that is here. I'm sure I showed you this. And then eventually we find the union. Okay, then you solve each individually. So let's solve for x. So I'll say x greater than, there's already 3, so I'll take 2 on the other side, negative 2, right? Greater than, this is going to be 1, right? Then x negative 3 and negative 2, right? So x less than negative 5, right? This is what we are having right now. So we have 2 possible solutions. Now, for this question, we are going to find the union. How are we going to find the union for this? So for you to know how to find the union, you need to understand interval notations, because we need to use intervals to find the union of these 2. And if you haven't understood, we are on this channel, there are 2 videos. There's part 1 and part 2, where I've taught interval notations, like everything from scratch. Okay, from scratch. So make sure that you watch the 2 videos. There's part 1 and part 2. I think I'll record part 3, where I'll solve the interval notation questions in this tutorial sheet. If you guys want me to record a video of me solving tutorial sheet, the questions on interval notations for this tutorial sheet, comment on this video so that I can know if you're interested. I skipped because I thought it is simple, like the majority of you have understood from the videos which I've recorded. So if you haven't understood, just comment here. I'll solve the interval notation questions in this tutorial sheet. Yeah, so let's proceed. So how can I write this in intervals? I can write this in intervals as, if you don't understand how I'm doing this, go and watch the videos on intervals. So since it is the values of x are greater than 1, so we are starting from 1 going to the positive infinity. And then this one, if I were to write it in intervals, basically we are saying that the values for x, it is starting from starting from 1. Since there's no equal sign here, so 1 won't be part of the set. That's why I've put this. But here we are saying less than negative 5, so mean that below negative 5, right? So mean that it's going to be, so mean that you're going this side. So it's going to be negative infinity, comma, negative 5. So this is how we can write this in intervals. So now we are going to draw the number line and find the union. That union is what you conclude as your final answer. And actually, remember that one which I was, this case which I've showed you here. This is the simple way. There is another way of solving the same types of questions, whereby here there is a less than symbol, using the same method of number line. That's why I didn't want to show you that, because it is involving. Okay, so let me just put 0 here. So I'll put negative 5 here. I'll put 1 here. Then what do I do? What I'll do here is that, so first I'll try to plot this one here. So for me to plot this, I need to show that I'm moving from 1 going to the positive infinity. And then for me to draw this, I need to show that I'm starting from negative 5 going to the negative infinity. So union is like on the region where we can find the values for this and this, then we unite them. So it is starting from here going to the negative infinity, and starting from here going to the positive infinity. So basically you can simply say that the union is, the final answer is like the range of, the possible values of x are this region, which we can describe with this interval notation here, is, I know like some of you don't understand this part. Trust me, there's a special video for that. If you have even subscribed on our platforms, I've taught interval notations deeper. But even on this channel, yeah, I've taught. Trust me, I've taught even on this channel, the video that is there, I've taught interval notations. Like I've taught. But on our platforms, I've even solved tutorial questions. So, but if you guys want me to solve on this channel as well, on this YouTube channel, make sure that you comment in the comment section. So here is going to be comma -5. Then you say union the other region, which is, I know maybe some of you might think I am not explaining properly here, because for me to explain properly, it would take me maybe another hour or 30 minutes. For me to just explain to you interval notations, like deeply, it would take me time. And this video is not really meant for that. This is meant to just solve for you. Okay, yeah, so you unite with this region, which is starting from 1 going to positive infinity. Alright, so this is the last question of the questions that I've prepared for you. These are the questions which I thought they are like the challenging ones. But I think I'll look for more questions. If there are questions that you would like me to solve in the tutorial sheet, like I record a video like this, make sure that you comment there or text me. And make sure that you subscribe to our online tutorials. Our tutorials are not physical, they are online, whereby you access full video lessons which we've already recorded for students, which students use. So you just watch them wherever you are at your own pace. You learn and you're able to solve. And we solve a lot of tutorial questions in our video lessons. Like every topic that I teach, I always solve tutorial questions from the exam. Exam questions from the tutorial sheet. Yeah, so make sure that you subscribe to A+ Academy, and also subscribe to the YouTube channel. I'll be uploading more of these. So if you want to be receiving the notification whenever I upload a video, make sure that you subscribe. And share this video with your friends who are at NS. Share this video to them. And I hope that you've enjoyed. And have a great day. I don't know if it's great night